The paper is out of 150, okay, and it's just made up of 4 topics. The 4 topics are basically statistics and regression, which normally carry plus minus 20 marks. Then we also have analytical geometry, which will account for roughly 40 plus minus. Okay, and then the trig, which is 50 marks, and then the Euclidean, which is 40 marks. So we can see that from this given scope, the trig is carrying much more weight, which is 50%, or not 50%, but close to 30% of the marks, which means if somebody can focus on at least getting 90% of these 50 marks, it will be a good kind of start. Then with the statistics, this should be all our marks in the back. Analytical, try your best, and then Euclidean, do what you can in that aspect. When I look at what is needed, especially with the breakdown, okay, we said we're looking at statistics. With statistics, what we need to remember is how to use our calculators. Okay, how do we use the calculators? Number one, to determine the standard deviation, to determine the mean, the variance, as well as the equation of this regression line. Because in most cases, such questions will be 1 mark or 2 marks in most cases. So if you try to go the long way and find the standard deviation, a lot of time is going to be wasted. That's why just get to know how to use your calculator and then move on. Then 2, we need to know how to interpret the standard deviation in terms of the normal distribution. But this will not be examined. Okay, we don't need that. Candidates are expected to identify outliers, okay, using common sense, using the scatter plots as well as the box and whisker. So in case there is a box and whisker observation that lie within this range or that range, are considered to be outlier. However, we shall not penalize anybody for not using the formula. So just by virtue of looking at the numbers, remember outliers are extremely too small values or extremely high values. So if we focus on that, we can get that as well. Then one other thing that is normally asked about standard deviation is when they try to look at the standard deviation and the mean. Okay, one standard deviation outside the mean, one standard deviation within the mean, and so on and so forth. Okay, same applies with the 2 standard deviation. So I'm going to start with the sample questions that are dealing with statistics. Okay, there we go, statistics. So under these statistics, we mainly have the univariate. Okay, univariate data. Which type of data works with mostly grade 10, grade 11 aspects of statistics. Then we're also going to have the bivariate data that has both variables or 2 variables, where we compare the correlation and the regression and how they are related. Okay, so with the univariate, that's where we find the standard deviation, the mean, the model class, the cumulative frequency, and the graphs, and so on and so forth. We need to remember this. Okay, each child in a group of 4, where all children was given the same puzzle to complete, and the time taken by each was recorded in the table below. So these are the intervals, and then this number of children will represent what we call the frequency. How many children complete the puzzle? So we just add up everything here. So that's a 12, plus 9 is 21, plus 7, 28, 36. Does that make sense? Yes, 36. Plus 7, 43, plus 2, 45. So we have 45 kids. Just add up everything there. Then calculate the estimated mean. So There are two ways of doing this. One, you could use your calculator straight away if you know how to. If you don't know how to use the calculator, remember the estimated mean of this, because this data is grouped. It's not the same as the ungrouped one, where you just add up everything and then find. So this would require to find the midpoint. This is 2 plus 6 is 8 divided by 2, that's a 4. Then 6 plus that is 16 divided by 2 is 8. Then it's going to be 12, it's going to be 16, it's going to be 20, 24, and probably 30. And then you just multiply this together, and then you divide by the 45. So this would give me, I don't know, do I need to go over that? That's fine. So 4 by 2 plus 10 by 8 plus 12 by 9 plus 16 by 7 plus 8 by 20 plus 7 by 24 plus 30 by 2. The answer we get divided by 45. So that would represent our mean or estimated mean. Then complete the cumulative frequency. I'll just try to squeeze it in here. So cumulative, we are adding and growing. Okay, so the first cumulative must be the same as the first frequency value. Okay, so this has to be a 2. And then 2 plus 10, that must give me a 12. 12 plus 9, that's 21. 21 plus 7, it's going to be 28 plus 8, it's going to be 36 plus 7, that's a 43 plus 2 is 45. So one hint about completing this cumulative column is the last cumulative value must be the same as the total that you have for the frequencies. That we're done. Then they want you to draw the ogive or the cumulative frequency. I'll do that. I'll sketch it somewhere here. Since I'm having a smaller frequency, how many classes do we have? It's 1, 2, 3, 4, 5, 6, 7. 7 classes there. Isn't that too far? Oops. There we go. So I'll say it's 1, 2, 3, 4, 5, 6. Probably 7. I think. So my smallest value is a 2. I can start and place a 2 here. That's my smallest. Then when I'm plotting, I'm going to use these upper classes. So I have a 6, a 10, is it a 14, 18, 22, 24, and then 26 is my last interval. Oh, there's even 30. So I can have a 30 there. Then what do I need? Now when I'm plotting, I'll start with this 6 is gonna go with the 2, the cumulative. So up here I can use 5, 10, 15. Then that's so small. Let me use 10 once, so that it is just down. 10, 20, 30, 40, and 50. So 6 is 2, somewhere there. And then 10, we said it's 12, slightly above. Then next is 21. So 14 is 21, slightly above 20. And then 18. 18, where are you? 18 is 28, slightly below 30. Okay, now it's bending. Then we have a 36. 36, we can just estimate it to be in between because it's close to 35. Remember, this is a graph, it's just a sketch. Then we have 43, slightly above. Okay, I'll take 45 to be somewhere. So we're saying it's a 43. Which one? For 22, no, for 26. This was a 26. And then this was a 8. Okay, so 43, slightly somewhere there, and then 45, somewhere there. 22 is what? 22 is a 36. Okay, that's fine. Just connect. And then this must be connected to the original, the lower class. So that would be my object. And then how do you determine the median? Remember, median is half. So what is a half of n plus 1? So 45 is the frequency. A half of 46 is 23. Then look for 23. 23. Somewhere. Draw a horizontal line up until it meets the graph. The different color. Okay, until it meets the graph. And then you must read the value from down there. Read the value from down there. But would that make sense with my 23? I don't know. Because now I'm getting something that is below 40, which is fine. No problem. But for as long as you get the idea of how this whole thing works. Okay, so 23 will give us a value that is somewhere there. So I'm not going to read the value from this because my x-axis is not that accurate. So just showing you how we get that. So answer that we estimate here becomes your median. Then question number 2. So with question number 1, in this case, they gave us group data. In other cases, they can give you the ungrouped. And then they talk about the variance and standard deviation and the quartiles and even the box and whiskers and things. So it's up to them. Just be prepared, be ready for anything. Question number 2, this is now the bivariant that talks about 2 pieces of data. Okay. Learners who scored a mark below 15 in a maths test were selected to use a computer-based program as part of an intervention. On completing the program, these learners wrote a second test to determine how effective the intervention was. Percentages are given for 15 learners. So we have a test for term 1. So test 1 and test 2. Okay, we can see. So from the observation, we can see that this test 1 marks are very low. And test 2 marks are improving. And as much as we cannot fail to get people that drop. Okay. But overall, there is an improvement. Okay. Then they want us to find the equation of the least square regression line. So remember that equation is given as A plus bx, or A plus bx. Some people write it as bx plus A. It's okay, it's the same thing. So you need to enter these numbers into your calculator. How does it work? You just have to press mode. Okay, and then look for start. And then after getting start, which is for statistics, you need to look for 2 VAR. Okay, which means we are dealing with 2 variables. Remember, initially we were just talking about 1 variable, 1 VAR. So you need to look for 2 VAR. Or if you can't find the 2 variables, you select the A plus the BX option, because this is now going to represent the regression option. Okay. So now, after getting this, you get 2 columns. Okay. Which 2 columns will be for X, and the other column will be for Y. Usually, the values that appear first on top I would prefer them to be the x values. Please and please and please take them to be the x values. And then whatever comes next, let those be your y values. So enter these numbers into the calculator. As you press your equal signs, just move on to the next value. You're getting the 49, enter 33 up to 60. Then after entering everything, okay, you need to press the AC or the on button for things to disappear. And then you're going to press shift or second function and 1. Shift and 1, you're going to get those options. Okay. In this case, you'll have to press a 3 or a 5 as long as it talks about the correlation and all of that. Remember, you must get the options of the A, the B, as well as the R. So some calculators can give them all at once, but others you have to go bit by bit. We need to revise on how to do this. So if I use my calculator, it gives me everything at once. It gives me the correlation coefficient, it gives me the A, even the means of everything. In this case, we're going to say y is equal to, because the A value that I'm getting is a 12,44. And then the B value is a 0,98. So write that in terms of an equation. Getting the A and the B values is just not enough. You need to rewrite them as an equation. So 12,44 plus 0,98x, or whichever way you want to put it. Then a learner's mark in the first test was 15 out of 50. Write down the learner's mark in the second as a percentage. So when we say 15 out of 50, it simply means that this learner got a 30. And when we look at these marks that we have, learners who scored below 50, they're telling us that these marks as percentages have been recorded. So what is 15 out of 50 times 100? That's more like a 30%. Do we have any learner that obtained a 30%? 15 over 50 times 100, which is 30%. They said write down the learner's mark as a percentage. So that is that. Then predict the learner's mark for the second test. So remember, the first test was our x. We can only do the prediction using the regression line. So we're going to say y is equal to 12,44 plus 0,98 times, let me use a 30 to give me the full percentage. Okay, that is 41,8 something, which is approximately 42%. So this is what we expect the learner to obtain within that part. Then 2.3. For the 15 learners above, the mean mark for the second test was this much. Now that's the average is this. And then the standard deviation is this much. Then the teacher discovered that he forgot to add marks of the last question to the total mark of each of these learners. All these learners scored full marks for the last question. When the marks of the last question are added, the new mean mark is this. Now, what is the standard deviation after the marks have been added? So one thing we need to know is that it's common practice for examiners to bring such scenarios where there was an error, they forgot that, and then there's either an addition or a subtraction of something that is consistent across the data pieces. Now, adding or subtracting anything only affects the mean, but the standard deviation is not affected for as long as it is uniformly applied across all the data pieces. Standard deviation will only stay the same because remember, it's just showing the variation of the mean from the data pieces. So here it's going to be 13,88%. no change. Okay. Then 2.3.2, what is the total mark of the last question? So initially it was 46, this much. Now it's 50,67. Let's subtract the 2. So 50,67 minus 45,67. It's 5 marks. So this is like 5%, which is more like 5 marks or 2.5. If the test was out of 50, then it will be 2.5. If it's a percentage, then it's just 5% of the marks, without any further calculations, because the average after dividing for everyone. All right, then that is to do with the statistics. It's unfortunate they never asked for the correlation coefficient in this question, but sometimes they can even give you the scatter plots themselves. Okay, so what we need to also highlight about the scatter plot, remember it's just a graph with points that are just across everywhere. So we have 3 formats. If the points are having no direction, then there's no correlation. If the points are showing an increasing trend, then it is a positive correlation. And then if the points are just sloping downwards, then that is a negative relationship or a negative correlation. So at times, if you're given just the scatter plot, they could ask you to plot or to draw the least square regression line. Or sometimes we call it the line of best fit. It's the same thing. It's like me having a surname and a name. Okay. So if that line is to be drawn, remember, you need to get the mean of the x values and then the mean of the y values. The line must pass through this point. It's a must. Okay. And then try to balance it up, whether it has an equal number of points above it and below, or it's passing through some points, and just play around with that. But it must rotate around this. Now, the other thing that we also need to know is, let's say they ask you for the correlation coefficient. Okay, so this is usually between 0 up to 1. And it can also be between 0 up to -1. In other words, it's between -1 and then +1. That is to do with the correlation coefficient. So if, usually we say, for as long as we have between 0 to maybe 0,4905, we usually call that a weak correlation. And then between 0,5 up to 0,6 or 6.5, I call it moderate. And then 0,6 up to 0,7 or 8, it's kind of good, strong. You know, I say good or strong, and so on and so forth. And then very strong is between 0,9 up until 0,99. Then if as long as the coefficient is 1, then that is a perfect relationship. Now, how do we relate these values to the points on the scatter plot? So for as long as the points are far apart from each other, then the correlation, yes, it might be positive, but not so good looking. Okay, so you can call it moderate or good or fair or something of the sort. If the points are so close to each other and they are showing some sort of pattern, then it is strong. Call it strong relationship. So when they ask you to describe, you'll have to tell us the strength of the relationship and then the direction. So it's a strong positive relationship, weak positive, or strong negative. Okay, based on your value here. Then from the same question, someone could also highlight, can you identify the outliers? Remember, outliers are extreme values, either too small or too big. Now, if you find a point that is far away somewhere there, automatically that's an outlier. If you find a point that is somewhere this side, far from the rest, it's an outlier. So just know how to operate and play around with that. Okay, next topic we have analytical geometry. Under this, just have to prove the properties of polygons using analytical methods. An example, if they talk about a parallelogram, just know about the diagonals, know about the opposite sides being equal and parallel, as well as the diagonals bisecting each other. Basically, for a parallelogram. Then to a kite, diagonals meeting at 90 degrees, the rhombus, same story, and so on and so forth. So for as long as we get to know about the properties of the polygons, because that's where most of the questions rotate around. Okay, so this must be understood, the concept of collinearity. In other words, points that are collinear. Okay, points are collinear if they lie on the same line, A, B, and C. These points are collinear, and the gradient between AB must be the same as the gradient between BC, the same gradient as AC. So you're expected to be able to use Euclidean into analytical. And in the length of a tangent from a point should be calculated using the distance formula. Then cocongruency is not going to be used here. Okay, so just this. For as long as we know how to use our distance formula, gradient, and perpendicular lines, parallel lines, and so on and so forth, then the rest will be history. Okay. Then on the same note, I'll just add the inclination from the grade 11 and the grade 10 kind of concepts. For us to get the gradient of a line, just get the tan of the angle of inclination. For you to get the angle of inclination, just get the arctan of the gradient and then move on. Do not be stuck just because we have one coordinate point and then they ask you for the gradient. Here they give you an angle. Please use what is given, read the question as far as you can, try to understand. Properties of triangles are also applicable under analytical geometry. Okay, let's see if we can get the 90% of these marks. So in the diagram, A, B, and C, and D, vertices of a trapezium. With a trapezium, you only have one pair of parallel sides. A, B is parallel to that, E is that of A with x-intercept of that, inclination of alpha with K that lies there. Good. 3.1, they want the midpoint of EC. Now someone once asked me, but now there's no line between EC. Just imagine if there was a line there. Or if possible, just sketch it. But there's no point of sketching. Just get the midpoint. You know that midpoint, get the x, negative 2 plus 2 over 2. Okay, do the same with the y. It's 0 plus negative 3 over 2. So which means it's a 0 and then a negative 3 over 2. So it's somewhere there in between. If I'm to draw that point, that line there. So that is your midpoint. Okay. Then the gradient of DC. So gradient is changing y over changing x. Please and please do not switch the values. Some people use changing x over changing y, which is wrong. So label this as your x1, y1, x2, and then y2. Then do the substitution. So we normally prefer to use y2 minus y1 over x2 minus x1. So minus 5 minus minus 3. I don't need this bracket, that's fine. And then x, we said with minus 2 minus 2. So when I simplify this, I'm going to have a minus 5 plus a 3 over minus 4. That gives me negative 2 over 4, which is negative. But why am I getting a negative? Yet the line is having a positive gradient. Oh, that's my problem. Okay, so this is a negative 2 over negative 4, which is a half. Okay, the line is increasing, so the answer has to be positive. So I'm getting a half there. Then the next one, they want the equation of AB. Now, we know that AB is parallel to CD. And for as long as the lines are parallel, the gradient of AB must be the same as the gradient of CD. So we have a point here. So we're going to say y minus 0 is equal to the gradient, which is a half, into x minus minus 2. So y minus 0 is a y. Okay, that's going to be a half x plus 1, if I simplify that. Okay, so which makes my point B to be 0 and 1, because I know that this is the y-axis and x is always 0. So that is 0 and 1. What's the next question asking for? They want us to get the angle of inclination. So the angle of inclination here, we can obtain it using this gradient here. Remember, we said to get the angle alpha is the shift tan over half. Okay, so shift tan over half, what we get from the calculator, we get 26,57. What was the question asking for? They wanted theta, but what I have is the alpha. Okay. Now, for me to get the theta, how does this theta relate with the alpha? How do they relate? So if I were to flip this page, which I don't want to do, let me see if I can flip it. Yeah, let me leave it there. So if I flip it in that format, I can see that this theta is an exterior angle of this and this triangle. Okay, so which means alpha plus 90 will give me the theta. So then, let me unflip it. So which means that it's going to be 90 plus alpha. The alpha plus 90 must give us a theta. So 26,57 plus a 90, you get your theta, which is 116,57. Answered. Then, can you prove that AB is perpendicular to BC? AB is perpendicular to BC. Okay. Now, coordinates of B, you have to state them first, because you have the equation of the line, you have the y-intercept as 1, and all of that. Please and please do not tell us that the angle is 90. The question is asking you, can you prove why that angle between the two lines is a 90? Okay, so what we know about perpendicular lines is that what we need to do, that if we get the gradient of AB multiplied by the gradient of BC, we should be able to get a -1. Okay? So this is what the question is asking for. Can we get the -1? If that is true, then we prove that the lines are perpendicular. So we already have the gradient of AB, which is a half. Okay? All we need is the gradient of BC. So 0, 1, 2, -3. 0, 1, 2, and -3. So gradient of BC is going to be changing y over the changing x, which is going to be -3 minus 1 over 2 minus 0. It's going to be -4 over 2, which gives me -4. So if I get -2 times my half, then tell us that since the gradient of AB times the gradient of BC is giving me -1, therefore AB is perpendicular to this. Is it AB or AB? Let me just confirm. AB. Perfect. So that is what you do. Then with the next part, they're telling us that E, B, and C lie on the circumference of a circle. E, B, and C. E, B, and C. So these points, they lie on the circumference of a circle. Please and please just imagine there's a circle there passing through those points. This circle of mine. It's fine. E, B, and C are lying on that. But what we just proved was that there's a 90 there. Okay. Then they want us to get the center of the circle. So we know that if that is true, then this EC is going to be a diameter. EC will be a diameter. And if EC is the diameter, the midpoint M that we got will therefore be the center of that circle. So what did we get for N? It was 0 and negative 3 over 2. So 0 and negative 3 over 2. That will be the solution for that. Then the equation of the circle in this format. So since we have the center, all we need is just the radius or the distance. So it's your choice. Either get the total distance, divide by 2, or you can get just the radius alone. So if I try to get the distance, 0, negative 3 over 2, what is that going to be? What's that going to give me? So I'm going to say, let me use negative 2 minus 0 squared plus 0 minus 3 over 2 squared. That will give me my r squared. So that's a 4 plus 9 over 4. That is 16 plus 9 over 4, which is 25 over 4. That's my r squared. Then I'll just go back and say x minus 0 squared, and then y plus 3 over 2 squared must give us 25 over 4. So it's x squared minus plus y plus 3 over 2 squared, 5, something like that. It would make much more sense. So those are 18 marks. Then question number 4, telling us that in the diagram, the circle is centered at M. Okay. The radius Km, is produced to L, a point outside of the circle, such that KML is parallel to y-axis. LTP is a tangent. The circle is that's the midpoint. Now remember, we have our Euclidean geometry involved. Since this is a circle, now we're talking of a tangent and a lot of things. First question, given that the radius is 5. Okay, so if that is a 5, show that B is a 4. Where is B? B is at T. So you're going to use just the distance formula. I suppose, how many marks is it? It's 4 marks, yeah. It makes sense for us to use the distance formula at that point. Is it so? I think so. So I'm going to say if I get my negative 2 minus 2 squared plus my b minus 1 squared must give us 5 squared. That's correct. Minus 2 minus 2, that's minus 4 squared, that's 16. Plus, that's going to be b squared. No, let me not open this up because it's going to cause issues for me. I am trying to run away from the quadratic. That's a 25. Move the 16 that side. B minus 1 squared is equal to 9. Find the square root. B minus 1 is plus minus 3. Move the 1 that side. So B can either be a 4 or B can either be a negative 2. So B is a y, which is up. So B is a 4. They told us to show that B is what? Perfect. So we isolate or we kill this because it's not applicable. Then determine the coordinates of K. Where is K? We're seeing that K is parallel, or it's at the bottom part here. Okay. So one thing we know about K is that the X is going to be 2. We just don't know what the Y is. Okay. But with the mark allocation of this question is 2 marks, so you don't need to overthink. Since the radius is 5, this is going to be 1 unit and then it's going to be 4 units down, so that I have pi 5. So which means k is a 2 and a negative 4, I suppose, because it's a 1 minus 5. Makes sense. Then the equation of the tangent, LTP. So for us to get the equation of this tangent, remember from our Euclidean, the tangent and the radius must be perpendicular. Tan perpendicular to the radius, or tangent perpendicular to the diameter. So we need to get the gradient of Tm, and consequently we shall obtain the gradient of LTP. So I'll start by getting the gradient of Tm. I had my center values as 2 and 1, 2 and 1, and this one was negative 2 and 4. Negative 2 and 4. So this is going to be 4 minus 1 of minus 2 minus 2, which is minus 3 over negative 4. Okay. Then the gradient of Lm, I'm going to multiply with the negative sign and switch around. It's going to be 4 over 3. Remember what we said, gradient of Tm times the gradient of Lm must give us a negative 1. Then we already have this coordinate, negative 24. So it's y minus 4 is equal to 4 over 3 into x minus minus 2, which is a plus 2. Open that up as you move the 4. Y is 4 over 3x plus 8 over 3 plus 4. Okay, so which means y is 4 over 3x. That's going to be 12, which is a 20 over 3. All right, so that becomes the equation of the tangent. So this is the procedure that we normally follow. Get the gradient of the radius, and then consequently determine the gradient of the tangent. Okay, then the area of LPK. Where is LPK? LPK. Okay, so LPK. Say 2 and negative 1. They want the area. How many marks is it? 7 marks. Okay, so looking at this, it's a long question with appetizing marks, but we need to find a way of how to break it down. What is the purpose of S in this question? Okay, you're not telling us anything about S, but let's see. Parallel lines, how are they going to help us? Because I need to break this into some shapes. Which shapes I can use to help me out? Okay. Okay, so what I'm going to do, if I break this into 2 shapes, let me just break it into 2 and see. If I draw a line from here up to there, that was a wrong choice of color. It's something like this. So that I have this as my first shape. Does that make sense? Yes. Yeah, I'm gonna have this as my second shape. Okay. Previous question. I want to be equation of the tangent. Okay, which is true, which is fine. Okay, so I need to get my coordinates here using that equation, because if this line is parallel, which means x is 2 here, but what is the y? So from that equation, if I replace x with a 2, that's going to be 8 over 3 plus 20 over 3, which is 28 over 3. Is that correct? That's what I'm getting. Okay, so I'll say it's 28 over 3. That's L. Then from there, I need to get my coordinates of K. I already have them sorted. Let me find the distance here. I need to get the distance there. I don't know if that's gonna make sense. But me splitting it up might even take longer. Let me flip this again and I see if it's gonna give us a better version of what we need. So what happens if probably I change my version and use this as my base, but then also try to extend this and create a perpendicular height somewhere, that I use this so that this is my base and then this is my height, because what I need will be the values of P, coordinates of P. If I can get the coordinates of P, I know my x here is still a 2. It's not changed. So I can get that distance and then I can get the distance between them. I think that is pretty quick than me breaking it down. Let me flip it again, guys. Okay. So let's get the distance. So it's going to be 28 over 3 minus 4. It's 28 over 3. So from my calculator, that's going to be 28 over 3 plus 4 over 3. That's 4. That's 28 plus a 12. So that's 40 over 3. So my base is 40 over 3. What I need is just this perpendicular height. So I need to get P. Let me try to use the midpoint formula since I was given S and haven't used it anymore. So negative 4 plus this, I'll call it xy, plus y over 2 must give us negative 6. Cross multiply. Negative 4 plus y gives us negative 12. Move it that side. Y is negative 8. That's negative 8. Our interest is the x value. The x value. Because we need this distance. I can get this negative 8 and replace it where there is y down here. So negative 8 is equal to 4 over 3x plus 20 over 3. Multiply through by 3. So negative 24 is equal to 4x plus 20. Move it that size, negative 64. Divided by 4 to get my x. So my x is going to be negative 16. How is it negative 16? Let me just repeat the process. Repeat the process. So we are multiplying by 3, which is negative 24. Is equal to 4x plus 20. It's a negative 44. 4x, which means x is negative 11, not 16. So negative 11 is what we have here. So the distance down here is going to be 2 and 11, which gives us 13 units. Then use your area formula. The area is a half times base times height. So a half times the base, which we got as 40/3. And then times your height, the height, which we're getting as a 13. Then multiply this together with your calculator, you get your answer. So the steps that will award marks, getting the coordinates of L, getting this distance down here, and then determining the points of P, getting that distance, and then applying the area, or the area formula. Then 4.4, they're telling us that there's another circle of x squared. Okay. X minus 2 squared plus y minus n squared equal 25. Determine with an explanation the values of n for which the two circles will touch each other externally. So for the two circles to touch externally, remember, they need to be touching at just one point. That's the logical part of it. It's touching externally. And now, with the information that we have, our center is 2 and 1. So this is the same as x minus 2, y minus 1 squared is also 25. X minus 2, y minus 1 is 25. But this is that. This I don't know, but that is that positive as well. We want the values of n. So for two circles to touch externally, the RA plus the RB must be exactly the same as the distance AB. So RA plus RB is giving us a 5 plus a 5, which is a 10. But we need the coordinates of n. Okay? We need the coordinates of n. What are we going to do? What are we going to do? So we're going to have some, so we can create a quadratic anyway. And see. Say it's y minus. So the sum, which is 5 plus 5, must give us a 10. Okay. So this 10 must give us this. So 2 and 1, and then we have that as 2 and n. And let's work around this. So that 10 is equal to, that's n minus 1 squared plus 2 minus 2, which will disappear. Okay. And then I need to square this if I'm talking about the distance formula as well. So the squares will go, so 10 is equal to n minus 1. Then when I move the one that side, I'm getting n as 11. That's what I'm ending up with. Okay, guys, so that is to do with that question of analytical. But remember the key aspects. How you get the equation of a circle, the x minus a squared, the y minus b squared is equal to r squared. A and b will be the center coordinates. Sometimes they will give you an expanded format of an equation. Okay? I'll say x squared plus maybe 6x plus y squared minus 8x, and maybe plus 16 is equal to 0. And then they ask you to change from this format to that kind of format. remember how to complete your squares. So a half of 6 is a 3. And then we do the same thing with the y. That's the negative. A half of 8 is 4. You square that. Plus 16. We're going to subtract 3 squared, which is a 9. And then subtract 4 squared, which is a 16. This cancels that. And then you have x plus 3 squared plus y minus 4 squared is equal to 9. So that's the format of this original. So that is that. Let's move on to trig. Trig. We said it carries most of the marks. 5.1, without, it's even highlighted. Sometimes we even write it in capital letters and say, without using a calculator, write the following expressions in terms of sine 11. Now that's our answer has to be having a sine 11 within it. So sine 191. So 11 is our reference angle. Okay, 11 is going to be our reference angle. Now the question is going to be, where do I find 191? So this is going to be 180, and then 191 is somewhere here in quadrant 3. And in quadrant 3, that's 180 plus something. So this is the same as the sine of 180 plus 11. But the sign in the third quadrant is negative. So that's the same as negative sine 11. Cos 2, we know that 22 is twice 11. So it's the same as the cos 211. We have two formats of this. And since they say they want it in the form of the sine 11, then we're going to use the sine format of the double angle. Okay, let me just say cos 211. So with the double angle of cos in terms of sine, it's going to be 1 minus 2 sine squared 11. That's what we need. Please, these double angle abbreviations and summaries are given on the formula page. Visit them, see them. 5.2, simplify this into a single trig ratio, so still compound angles. We need to work this out. This is going to be a reduction. This is just a compound format. Okay, so I'll take out the negative sign. It's going to be negative into 180 minus x plus root. This is going to be sine x cos 45 plus cos x, and then the sine of 45. I'll just put this in brackets. So the cos of a negative angle is the same as the cos of positive, so I'm not going to stress with that. 180 minus is in the second quadrant. So that's going to be negative cos x. Okay. Plus, I'll say root 2. This is going to be sine x over root 2 plus cos x over root 2. Then when I open it up, it's going to be cos x negative plus sine x and then plus a cos x. So this cancels that. That is the single trig ratio that we want. Okay, remember this root 2. Remember the question never said do not use a calculator, so you can use a calculator. You can even use the root 2. You still get the same thing. 5.3, given that the sine of p plus the sine of q gives us 7 over 5. Hey, how do we do this? And then p plus q must give us a 90. What's going on here now? Without using a calculator, determine sine 2p. Let's see. Sine 2p is a double angle, so it's 2 sine p and then cos p. 2 sine p cos p. Then, how do I create this within this? I can square this. I square that as well. So that's going to be sine squared p plus 2 sine p I was given sine and sine. Will that make sense? It's not a cos, it's a sine. Then I need interpretation of this nicely. So P plus Q is a 90. Okay. Let's say we have the sine of 30 plus the sine of 60. Just say, since P and Q are complementary, which means the cos of 30 is going to be the same as the sine of 60. Yes. So I'll say the sine of P plus the cos of P squared must give me 7 over 5 squared. Open this up. That's going to be sine squared P plus 2 sine P cos P. Wait a minute. Does it mean that is... No, it's fine. Plus cos squared P gives us 49 over 25. We know that this and this is going to give us a 1. Okay? But we said they want P. They want P. Okay, I'm going to replace this with that. Sine 2P is equal to 49 over 25. Move it that side. Sine 2P is equal to 16 over 25. Then I can use my arc sine of 16 over 25 should give me 2P. And then I'll divide it by 2. And then I should get my P. What do they need? Do they need the value of P or the ratio? Determine, the value of sine 2P. Then we've answered it. We've answered it. It's 16 over. No. We said 49 over 25, which is correct. When I subtract 1, it's not 16, it's 24. Yeah. All right. So before I move further, let's go back to the guideline. Remind ourselves what is expected of us. We don't expect these things of grade 10, the reciprocals of the chord, sec, and what that is out. Three graphs will be on relationship simplification, determining the points of intersection by solving, although the characteristics should not be excluded. Okay. Then the reductions and the rest. So there's nothing much that the guideline is telling us, which means we need to know quite a lot about trig, all the details. Then 6.1, determine the general solution of this thing. So the hints on finding general solution are that try to create the same trig ratio across, if possible. How is this going to work? We can open this up and say cos x, cos 30, plus the sine x, sine 30 must give us 2 sine x. So we know that the cos of x is root 3 over 2. Okay, and then the sine 30 is a half. This must give us 2 sine x. Move this, you subtract. So root 3 over 2 cos x is going to give me 3 over 2. Because it's 2 minus a half, this is 1.5. That's sine x. Divide both sides by 3 over 2 cos, because I need to take the cos this side so that I get a tan. Okay, then I'll divide it by this side. Is it 3 root 3 over that? No, it's going to be root 3 over 3. Then I can get my reference angle, so the shift tan of root 3 over 3. That gives me 30. So, since the tan is giving me a positive value, and tan is positive within the first quadrant and the third, so it's going to be 30 plus k times 180. This is limit of integers, since it is 10. Remember, the period of tan is 180. Then the other one is going to be in the third quadrant, which is going to be 210, because it's 180 plus theta, 180 plus 30 is that. K times 180, k is limit of integers. So that is what we need to have, unless if the question gave us a restriction. But if there's no restriction, we need to have the full solution. 6.2, with the graphs. The diagram, the graph f of x is this, g of x is that, and drawn between negative 1, 8 and positive, a, b, x intercepts of f, the two graphs intersect at c. Okay, and b as seen. Minimum and maximum turning points, respective. Right. Of the minimum and maximum of f. Okay. They want the coordinates of a. X intercepts this one. So if we have a graph of f, and at this point y is a 0, how many marks is it? It's 1 mark. So with a graph of course, we can say that shift cos of 0 will give us x minus 30, because I need to solve a replace that with a 0. This is going to give me a 90. Because x minus 30, move the 30 that side, x becomes a 120. So let me call this 120 and a 0. And then for me to get c, we said it is the turning point. And we're still dealing with a cos graph. And if it's a turning point, then this y value is going to be negative 1. That's all I know about that turning point, since our amplitude here is a 1. So if that's a negative 1, just going to replace it again into that. So I'll say the shift cos of negative 1 should give me x minus 30. Is that going to make sense? Negative. Okay. The shift cos of negative, it's not making sense, because I'm getting something like that 0 is a 90, that's going to be a 0. We expect it to be at a 30. It doesn't make sense. Let me see. Okay, let me just look at it in this format using the shifting. Okay, how many degrees did the graph shift? That's what I need to look at. Okay. So if I'm looking at it that way, because the shift cos of this is giving me 180, and then this 180, this graph was moved to the right, so which means it's going to be 150, negative 150, because I move it that way, plus 30. and then -1 is said. Okay. All right. Determine the values of x in the interval for which both graphs are increasing. So when the graphs are increasing, which means they are rising up. Okay. So at this point, this graph is increasing up to that point. And then from this point, this graph is increasing, which means we're going to end at this point. So we expect the original course graph to be here, this turning point. But now it was shifted because of the 30. So we expect this to be a 30. Okay. Now, with this graph of sine, we expect the sine to be at the maximum at a -90 and at a +90. That's when it reaches the maximum or the peak. So between these 2 points, that's where the 2 graphs are increasing. So we're going to say -90 is less x is less 30. Yeah, that's what I see. And then if the graphs are shifted 10 units to the left, same story, where do we find f to be above g? Where is f above g? So we can see that from this point and this point. So we said this was 150 negative. And then the graph is being shifted to the left, which means it's going to be -160 to the left. It's going to be a 20. Okay. So that is going to be -160 is less x is less 20. And then find the range of that. Okay, so we have 2 sine x and then there is a +3. So let's start with the range of the sine 2x. So y is equal to 2 sine x. The range of it is between 2 and -2. That's what we saw from the graph. We expect the highest point to be a 2 and the minimum to be a -2. Why is that so? Because of this amplitude. Then, what if we add a 3? Okay, we're moving it upwards. So which means we're going to have a 1 and then a 5. This is going to be the new range for that graph. Now, if these numbers now are being raised to the 2, so 2 to the 1 is going to give us a 2. 2 to the 5 is going to give us a 32. So these are the new range values for that part. Okay, so that is how the trig is going to be answered. Remember. Okay, your reduction. Okay, remember to do your sketches if asked to do so. And then remember your compound angles and then the double angle identities. We need to remember all this as we go for the trig. And then with the graphs, just know how to interpret and work around with the graphs. The amplitude, the period, and range, all those things. Let's look at question number 7, which is the 3D trig. Okay. So in this question, what we normally use is 1, what we call the sine rule. A over sine of A is equal to B over sine of B, or C over sine of C. We also use the cosine rule, which is A squared is equal to B squared plus C squared minus twice BC cos of A. And then we also have what we call the area rule. So with the area rule, you need to look at 2 adjacent sides together with the angle. So in the diagram below, CGFB and CGHD are fixed walls. Rectangular in shape and vertical, the horizontal steel poles are erected, and so on and so on. So BC is x, CD is x plus 2, BAC is a theta, BAC is a theta, AC is 2 theta, and then ECD is 60 degrees. Okay, so all that information is being represented within the drawing. So there's no need to stress. So 7.1, they want us to calculate AC in terms of X and theta. Okay, so we said any two sides and the angle between the two sides will help us. Now this question is asking for the length of AC. This is AC in terms of X and theta. So we can see, just focus on just the small details. Focus on just this triangle. So this triangle is a right angle triangle. So which brings us back to the trig ratios of the soccer. Okay? Now, they want AC, which is the hypotenuse. We are given the opposite. Now, this is opposite to the theta, in as much as to be adjacent to this angle. So I'll have to use the sign and say the sine of theta is the opposite, which is x over AC, which means that my AC is going to be x over the sine of theta. Okay, so that is that. Then they want GE. Where's GE? This is G. Where's E? So they want this this entire thing in terms of X. In terms of X. Okay, so what we also know is that since this is a rectangle down here, if this is x plus 2, even that must be x plus 2. Okay, what else do we need? What else do we need? We need 60. Is there any other information they give us? I say GE. No, CE. Hello. What's looking forward, Baba? Okay, CE. In terms of it, so we need this one. In terms of, so we need the hypotenuse. This is gonna be the adjacent. So we use the cos. So cos of 60 is equal to the adjacent, which is x plus 2, over the hypotenuse, which is CE. Let's make CE the subject. CE becomes 60 cos of 60 over x plus 2. But the cos of 60 is a half. So we can play around with it and does that make sense? CE the cos, which is this, over that. No, it doesn't make sense. It's supposed to be the other way around. All right, so it's going to be x plus 2 over the cos of 60. Then when you simplify that, x plus 2 divided by a half, which is twice x plus 2. Okay, that is sorted as well. Then 7.2, show that the area of the roof ACE. Let me change it and see. ACE, the area of this entire roof, is given by that. So remember, we said we have this, we have that, and then we also have an angle in between. So let's just apply that and say the area rule is going to be a half times, we said AC times CE, the sine of ACE. Okay, so that's a half. Our AC was x over sine theta. And then our CE has been twice x plus 2. We are multiplying it by the sine of twice theta. Okay. Simplify the top part. That's going to be twice x into x plus 2. This is sine twice theta over 2 sine theta. So this this cancels that. I can expand that. It's 2 sine theta cos theta. I'm multiplying it now with x plus 2 over sine theta. So this sine cancels that. So we have is also x here. Okay, there is a 2, there is a 2, now the x and the x, the bracket, and then the cos. So that is the roof. Then if theta is 55, BC is that, calculate the length of AE. This. So if theta is 55, that is 2 times 55, which is 110. Then they gave us this distance. BC is a 12. BC is a 12, which means x is a 12 in other words. So this length here is going to be 12 over the sine of 55. And then this length here is going to be 2 times 12 plus 2, which is 2 times 14, which is 28. We can simplify this, and then we use the cosine rule to get that. Okay, so since we're looking for AE, I'm going to say AE squared is equal to AC squared plus CE squared minus twice AC times CE, the cos of AEC. Now it's ACE. ACE. Okay, then it's going to be the square root. When I punch that into my calculator, that's 12 divided by the sine of 55. Okay, I'll just rather use it at once. Okay, 12 over the sine of 55 squared plus the CE, which we said is a 28, minus 2 times 12 over sine 55 times the 28, and then the cos of 110. Okay, then you get your answer. Whatever answer you get, that will be the final part. So this, under this 3D, sometimes they talk about inclination, depression. It's not a big deal under the angle of depression and inclination. What we need to know is about the sine rule, cosine rule, as well as the area rule, and how to apply them. They will be given on the formula page as well, except for the area rule. I haven't seen that much. Okay, then question number 8. The last few marks. Question number 8. So this is Euclidean. Under Euclidean, we need to remember the 9 theorems of grade 11. Sometimes it's called 11 theorems, 9 to 11. Then some few theorems of grade 8, 9. And then we also need to know about some proofs. Okay. So here, measurement can be tested in the context of optimization, but this is calculus, which we're not going to look at, but we can only use it under a 3D tree. Okay. Composite shapes could be formed by combining a maximum of 2 stated shapes. So the maximum that we can go to is 2 shapes. The following proofs can be examined. A line drawn from the center. That's theorem number 1. We need to know how to complete the statements, do some proofs, okay, and then the application of it thereof. Then a line drawn from the center that bisects the chord will be perpendicular, so this is like the converse of that. And then a line drawn from the center bisects the chord, that is what we've seen. Then the angle formed, which is the angle at the center, we need to know at least how to prove this one. This is a problem. Okay, it's a stubborn theorem that keeps on coming and coming. Even this one, opposite angles of a cyclic pi. This is also a stubborn one that could be asked. Then the next one, the angle between the tangent and what? This is the tan chord. It's also examinable. 1, 2, 3. Whenever they ask a proof, at least one of them. Line drawn parallel to one side of a triangle divides that. That is another theorem which was done at grade 12 level. And then the equiangular triangles, which is also one theorem that we like to prove. Then the corollaries derives from the theorems and axioms, angle in a semicircle, equal cos subtechnical angles, and so on and so forth. So this we need to remember, okay? And also the acceptable reasons, okay? Under the theorem statements for the lines, the triangles, when it comes to the circles, these are the reasons that we can accept. You can abbreviate them the way they have written them here. Okay, and then the quadrilaterals, this is all we have. And then that is the Afrikaans part of it. Let's move on now to the application of the questions themselves. Okay, so in the diagram, O is the center of the circle, and LOM is a diameter. This is interesting. ON bisects the chord at N and S are points drawn, the other side LM with respect to P. The chords PM, MS, MT. Where is MT? Is there MT? This is M, this is T. And ST are drawn. PM and MC are equal, as they have indicated. MTS is a 31. All right. So now, by looking at this, we can see two theorems in one. I can say that. Number one, I can see a line that is drawn from the center to the chord that is being bisected. Then I can also see the angle at the center and then the angle at the circumference. And then those other sub-theorems from both. So determine this one's the size of each of the following. MOS. What's the size of MOS? So the angle at the center. So this is going to be 62. So tell us it's a 62 and the reason. Angle at the center is twice angle at the circumference. So 1 mark for the reason and then 1 mark for the statement. Okay. So I'll put my 62 there. And then they want the size of L. So this L and this T have to be the same. Why? Because they are subtended by equal chords. So I'll call it a 31. And then we can say equal chords, subtend equal angles. Or you can just tell us equal chords, equal angles. No problem. 1 mark for each. Then can we prove that ON is a half of MS? ON is a half of MS. So we know that MS is the same as PM. Okay, MS is the same as PM. So if that is true, we know that O is the center of this line, which is diameter, which means this is a radius, that's also a radius. From the question, they told us that this is the same as that, which means we're going to have what we call the midpoint theorem. Okay, midpoint theorem. So if we can prove that it's a midpoint theorem, then we're good to go. So step number one, we're going to say that OL is the same as OA radii or radii of the same circle. And then Ln is the same as NP, that is given, we're told. Okay. Therefore, ON is going to be a half of MP. This one is going to be the midpoint theorem. Okay. That is that. 8.2. 8.2, which is now the application. Okay, so in the drawing, the diagram, there's a triangle. There's a point on that. And that's such that AK is 3 is to 2. N and M. N and our points on A is such that we have lines that are parallel. Okay. AM to MC. So from here up to there is a 10, and then from here up to there, keep 23. Okay. Then determine with reason the ratio of AN to AM. So what we can see is that when you look at the proportions, you can focus on this triangle here, since we have these lines that are parallel. Okay. We can look at the overall ratio. We know that AN over AM should be the same as AK over AB. Okay, so what is our AK? That's a 3. What's our AB? It's a 5. So I'm going to have 3 over 5 to give a reason that we have a line that is parallel, or we have lines that are parallel to one side of a triangle. Alternatively, just call it the proportionality theorem. Okay. So 3 over 5. Then CL to LK. CL to LK. We said AN is 3 over 5, which means this is going to be 2 over 5. Now, if this is a 10, you just want to analyze it in that format. If this is a 10 from here to here, because now the triangle that I need to focus on is this triangle here. This triangle. Because I know that from here up here is a 23. But then what is the distance? What proportion is this of the 10? So 2 over 5 times 10 is going to give me a 4. Which simply means that this is going to be like 4 units here. Now they want the ratio of CL to LK. So I'll say that CL to LK must be the same as CM over NM. Okay, so that's going to be 23 over 4. So what we do, start by getting the NM and then use the proportionality theorem to represent that. All right, so that's done. Question number 9. There's the diagram. We have some tangents that are drawn from point M outside the circle. That is a straight line passing through the center of the circle. Mn is produced. This is produced to K such that these two sides are equal. Those are drawn. Let K be X. Good. They want us to give reasons. The size of N1 in terms of X. This is N1. Okay. So what I'm going to do, 6 months module. Okay, what I'm seeing is that this is X. Okay. Which one is the tangent? Tangents are drawn from M. And it's okay. I sorted. This is sorted. So I'm going to say that P1 is X. Angles opposite equal sides. And then I'm going to say that M2 is going to be twice X because it's the exterior angle of the triangle KMB. Okay, so that is 2X. But I know that MB is the same as MN. Reason? These are tangents from a common point or from the same point. So which means if this is 2X, which means therefore B2 must be the same as N1. Okay, it will be still angles opposite equal sides. Then I'll get my 180 minus 2x divided. So which means n1 is just 90 minus x. That is my understanding of this question. You can have a simpler way or a quicker way, but that's how I would have gone about it. Then can we prove that BA is a tangent? BA is a tangent to a circle passing through K, B, and M. Let me just get a different color. Okay. So if we assume that there's a circle that is passing through K, B, and M. For us now to prove that this is a tangent, we need to aim at getting this B3 to be X. If we can prove that B3 is the same as K, then we shall have our tangent. Okay, that is one. Yeah, I think that is it. Let's prove that B3 is X. Okay, so what I'm going to do in this case, the tan code is not going to work to only work in the proof. I need to find what is my B3. What is my B3? B is passing. Wait a minute. They told us the straight line from B passing through the center meets MN at A. So this is the center. Okay. Do I need to construct? Do I need to construct? Yeah, I think if I can just construct and that is not a big deal. Not a big deal. So now we know that B1 plus B2 is going to give us a 90. That is angle in a semicircle. Even from what we just said, this is a 90 minus x plus the x. This whole thing must give us a 90. Okay. Then if that is true, which triangle should I focus on? We can have B3 being 90 minus the B2. 90 minus the B2. Okay. So why am I saying that? Because this is a tangent and then this is a diameter. So I'm going to say tan perpendicular to the diameter. And then if this is 90 minus x, so it's going to be 90 minus 90 minus x. 90 minus 90 plus x, so which means B3 is x. Now, since B3 is the same as K, which is x, therefore that line BA is a tangent. The reason, I'm going to say the converse of the tan chord. Converse of the tan chord. All right, so that is question number 9. Then question number 10, we are given the diagram ABC and DF are drawn such that those angles are the same and that information. Then they ask us that in the diagram, the answer book, can we prove the theorem? So whenever they ask you to prove, especially this theorem, you are expected to do some bit of construction. Okay. So what we do normally is that construct a line such that this is a midpoint of that, and this is also a midpoint of that line. So if I call this T and P, so I can say that construct a line TP such that T lies on the lies at the midpoint of AB, and then P lies at the midpoint of BC. Okay. Then what we're going to do? Is that in as much as this is a midpoint, also ensure you can even write a statement and tell us that construct TP on AB and AC respectively, such that AT is the same as DE, and then AP is the same as DF. So if this is the same as that, this is the same as that, then which means even the angles are going to be the same. Then break down with one triangle at a time. So I'm going to look at ATP as my triangle, and then DEF, and then compare for congruence. So I'm going to say that AT is the same as DE, and then I'm going to say that AP is the same as DF, which means that TP must be the same as EF. This is going to be the remaining side of the triangle. Okay. Remaining side of the triangle. Or you can just tell us that the angles are the same. A and B are the same. Okay. So therefore, ATP is congruent to DEF. Okay. That is true. So if that is true, which means this X must also be the same as that, and then that angle. And if that is correct, we can say that this implies that the line TP is parallel to BC. Okay? That those lines are parallel because those are corresponding angles. And then from there, since we know about the midpoint theorem, then just go on and compare the ratios and tell us that if I have my AT over my, let's say AB over, okay, so I'm going to use AB divided by my AT. This must be equal to my AC over my AT. But remember I said AT is the same as DE, and AP is the same as DF. And then you draw your conclusion. Okay, then the second question is telling us that in the diagram, O is the center, okay, of the circle, that's a tangent, straight line passing through that. We have chords, perpendicular lines, and they intersect. Can you prove that DGF is required? DG. Now there are three aspects when you are proving a cyclic chord. Number one, we can look at the opposite angles being supplementary. We can consider the exterior angle of a cyclic chord, or we can look for the bow tie. But based on this drawing, I don't see any bow tie because there's no line connecting over it. So bow tie is out. Exterior angle will be a bit tricky, so I'm going to use the opposite angles because I know that G3 plus G4, it will give me 90 if I focus on triangle DGE. Angle in a semicircle. But we were told that this is a 90. Okay? If I get DOF, plus DGF. I'm getting 180. Therefore, DGFO is a cyclic word. And the reason is going to be opposite angles of a cyclic word. And say complex as well. Having done that, then they want us to prove that GC, okay, is the same as CF. For us to determine that, we have to make sure that this angle is the same as this angle. We just need to prove these two angles are the same, which means that will be that. So for starters, we can say that G2 is the same as G. We can use the tan code because it's a chord, it's a tangent. Okay, so this is the same as that. Then what else do we see? I haven't been sorted. How many marks is it? It's 5 marks. Why is it so much? Okay, so I'll say that's a tan code. But then we know that F1 is the same as D. The reason is going to be the exterior angle of a cyclic word. Because remember, we proved that that is a cyclic word, which means there is a mini circle here. And that's a mini circle. This angle must be the same. Okay, so therefore, or we can say that it is the same as F1. And if that is true, then GC is going to be the same as FC. The reason is going to be sides that are opposite equal angles. Okay, and then you're done. Then it's further given that CO is 11. CO. All of this is 11. Okay, DE is 14. DE, the diameter is 14. That's a 7. Then they want the length of this. They want the length of this. Where is this? It's from here up here. So if the radius is 7, so from here up here is a 7. What's that? It's going to be 4. Just tell us 11 minus 7, which is a 4. And then they want the length of CG. CG, where's CG? This distance. But we say that this is the same as that. From here. This is 4. All right. I'm gonna look at it as CF. So it's gonna be a bit lengthy because I need to prove that some triangles are similar. Okay, how many marks is it? It's 5 marks. Yes. So I need to prove that CGB, this triangle, is similar to triangle CAG. If I can prove that the two triangles are similar, then I can go ahead and compare. Okay. So that is how you're going to go about that. And then the size of E, we can use Pythagoras, I guess. Size of E